Hi, ladies and gentlemen. Notes 2.3 are on theoretical probability, and we're looking at our second day of theoretical probability. So, just a reminder that the probability of an event is always going to be equal to the number of successful outcomes over the total number of possible outcomes. Okay, so to calculate theoretical probability, all outcomes are equally likely. What does this mean? Essentially, it just means that each event has the same chance of occurring because conditions are fair. Okay, so each event has this same likelihood because conditions are fair. Okay, so ways of representing probability outcomes. Tree diagrams are one way of representing possible probability outcomes. Okay, and we did one the other day when we did notes 2.2, but let's talk about how to do this right here again. Okay, so draw a tree diagram for tossing a coin twice. What are the possible outcomes? So we've got toss one, and under toss one we've got two outcomes. We can either get heads or we can get tails. Then we've got toss two, where you've tossed it a second time, and off of the heads you can either get heads or tails, or off of the tails you can either get heads or tails. Okay, so that means that all of our possibilities are as follows. So first of all, how many possibilities are there going to be? We look at our last part and we count up how many there are. So there are 1, 2, 3, 4 total possibilities. So our first possibility is we could get heads followed by heads. Our second possibility is we could get heads followed by tails. Our third possibility is we could get tails followed by heads. And then our fourth possibility is get tails followed by tails. So we have 4 possible outcomes. Okay. So let's take a look at example number 2. Example number 2 says that Eva is at a carnival. One of the carnival games asks her to pick a door and then pick a curtain behind the door. There are 3 doors and 4 curtains behind each door. How many choices are possible for Eva? Draw a tree diagram to determine your answer. So the first thing she's going to do is choose a door. Okay, so it says right here that there are 3 doors. So that means that coming off of the door, there are 3 possibilities. So we can either get door 1, door 2, or door 3. Once she chooses a door, the next thing she needs to do is choose a curtain. And if she's choosing a curtain out of 4, off of each one of these guys right here, she has 4 possibilities. Okay, so she could either get curtain 1, curtain 2, curtain 3, or curtain 4. And that's possible for no matter what door she gets first. So curtain 1, curtain 2, curtain 3, curtain 4. Okay, so that means that altogether she has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different possibilities. So therefore Eva has 12 possible choices. But here's the thing, you're not going to want to do this multiple times, right? Like you're not going to want to draw tree diagrams if there were 20 doors and 15 curtains. That's just too long and too much. So how do we figure out how many possible choices there are a little bit more easily? We do something called the counting principle. And the counting principle is just to multiply, all you have to do is multiply the number of options for each event. Okay, So I'm going to flip back to page 6. So for example, for question example 2 right here, we had event 1 was doors, and then event 2 was curtains. And there were 3 options for doors and 4 options for curtains. Because the counting principle says to multiply the number of choices there are, 3 times 4 is 12, so there are 12 possible choices, which is exactly what we got here. Okay, let's talk about what to do for example 1 if we just wanted to figure out how many possible outcomes there are. So we've got toss number 1, and then we have toss number 2. And if I toss a coin or flip a coin, then I have 2 choices for my first toss, and I have 2 choices for my second toss. Multiply those together, 2 times 2 is equal to 4. So I have 4 possible outcomes, okay? So you can calculate this by either drawing a tree diagram or by using the counting principle. Those are some options here. So example 3 right here is an example where you're not going to want to draw out every single possibility. So Ontario issues license plates consisting of 4 letters followed by 3 numbers. There are 26 letters and the letters may be repeated, and there are 10 digits and the digits may be repeated. How many license plates can be issued in Ontario? So you're not going to want to draw a tree diagram with 26 options off of the first from the beginning, and then another 26 options off of our first option. That's just going to be it's going to be too many options, and we won't have enough room to do this. Plus, it's just not efficient to do something like this. So a quicker way to answer this is to actually use the counting principle. So if there are 26 letters and the first 4 things are 4 letters, so what we'll do is we'll show right here, it says it starts with 4 letters. So we're going to say letter, 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 followed by 3 numbers right here. And you know what, let me do this in a different color. So it's going to be followed by 3 different numbers, so followed by number, number, and number. So there are 26 letters, and the letters can be repeated. So right here, what this is telling me is for my first option, I have 26 choices to choose from, A through Z. Okay, and then for my second letter, I still have 26 letters to choose from because it doesn't matter if the letters are repeated or not. And then I've got 26 options for the third letter and 26 options for the fourth letter. And I'm going to multiply all of those values together. Okay, and then for numbers, I have 10 options for the first number, and it says the digits can be repeated, so I have 10 options for the second number and 10 options for the third number. And since the counting principle says to multiply these values, I'm going to go ahead and multiply them. So I'm going to take 26, multiply it by itself 4 times. So there are my 4 26s. Then I'm going to multiply it by 10, and then another 10, and then another 10. So that means right here that I have 456,976,000 possible options. And if you did that in a tree diagram, that would just be brutal, right? So here we've got 456,976,000 possibilities. Okay? So we're good for example number 3. Example number 4 says that Fraser, Amanda, and Jesse have each won a t-shirt from West 49, a store grand opening event. Each shirt will be randomly assigned to 3 winners. 1 is red, 1 is black, and 1 is green. What is the probability that Fraser will receive the black t-shirt? So one option we have is to draw a tree diagram, but another option is to use a table. So in the table, record all the different possible ways the t-shirt can be given to the 3 people. So one option is that Fraser could get the black one, Amanda could get the red one, the red t-shirt, okay, and that Jesse could get the green t-shirt. Okay, another option is that Fraser could still get the black t-shirt. Amanda this time would get the green t-shirt, and then Jesse could be the one to get the red t-shirt. Okay, and those are the only options we have for Fraser to get the black shirt. Now the next option is for Fraser to get the red shirt, and then this time Amanda would get the black shirt, leaving Jesse with the green shirt. Or Fraser could still get the red shirt, but Amanda would get the green shirt and Jesse would get the black shirt. Okay, and those are the only possibilities for Fraser to get red. So lastly, we're going to see what options Fraser has for green. So if Fraser gets green, that means that Amanda could get red and Jesse could get black. Or if Fraser gets green, that means that that Amanda would get black and Jesse would get red. Okay, so it says right here, in how many different ways can the 3 shirts be distributed? Well, we've got 1, 2, 3, 4, 5, 6 different ways. So 6 different ways. So 6 different possibilities. So we could also use the counting principle to figure this out by seeing, well, Fraser needs a shirt, Amanda needs a shirt, and Jesse needs a shirt. Well, Fraser gets 3 choices, either red, black, or green. Amanda only gets 2 choices because Fraser will have taken 1, and that leaves with Jesse with just 1 choice. So 3 times 2 is 6, times 1 is also 6. So that's how you can figure out that there's 6 different possibilities. So part B says, in how many of these arrangements does Fraser receive the black t-shirt? Well, Fraser receives the black t-shirt in choice 1, in option 1 right here, and then in the second way that we've arranged it. All the other ways, he doesn't receive a black t-shirt. So there are 2 arrangements that result in Fraser getting the black t-shirt. Okay? So part C, what is the probability that Fraser will receive the black t-shirt? The probability is 2 out of 6. So we'll just say probability of black right here is 2 out of 6. Both of these numbers are divisible by 2, so that reduces to 1/3. So we can also say the probability of black, if I were to divide 1 by 3, I will get 0.3 repeating right here. So we can say it's 0.33, or we can say that the probability of black is just 33%, and then we're good to go for this question. Okay? All right, example 5. What is the probability of rolling doubles with a pair of dice? Complete the table below showing all possible outcomes. So it started for you, and it says, in how many different ways can the 2 dice be rolled? So let's complete the table first. So on the first die, you could get a 1. On the second die, you could get a 1, so it'd be 1, 1. You could get 2, 1, 2 on the first roll, 1 on the second roll. You could get 3, 1, 3 on the first roll, 1 on the second roll. You could get 4, 1, 4 on the first roll, 1 on the second roll, so on and so forth. I could also get 5 followed by 1, and I can also get 6 followed by 1. Here, this is saying I could get 1 on the first roll and 2 on the second roll. I could get 2 on the first roll, 2 on the second roll. I could get 3 on the first roll, 2 on the second roll, and I could keep going that way. So right here, I could get 4 on the first roll, 2 on the second roll, 5 on the first roll, 2 on the second roll, or 6 on the first roll, 2 on the second roll. Okay? I want you to finish this chart up and then compare your answer with mine to see what you get. So make sure that you had pressed pause to make sure that you did this on your own, and check to make sure that your answers are right here. Take as much time as you need. If you're confused, let me know, and I'd be more than happy to help you out. So question A says, in how many different ways can the 2 dice be rolled? So how many possible outcomes are there? Well, right here I can see that there are 6 outcomes for the first row. Then I have another 6 outcomes for the next row, so that's 12 altogether. Then I have another 6, then another 6, then another 6 right here, and then another 6. So that means I have 36 outcomes. But I could have figured that out without drawing this table, because on my first roll, or my first die, I have 6 choices. And then on my second die, I also have 6 choices, and 6 times 6 is 36. So question B says, in how many ways can doubles be rolled? So let's go ahead and circle all the ones that were doubles. So doubles means you get the same number on each roll. So we can get a 1 followed by a 1, a 2 followed by a 2, so on and so forth. So if you circle all the ones that work, we end up getting 6 out of the 36 outcomes. So there are 6 ways that doubles can be rolled. So part C says, what is the probability of rolling doubles? All we have to do is take the number of possible successes, which is 6, over the total number of outcomes, which are 36. So that means that the probability is 6 out of 36. I need to reduce this. I know that both 6 and 36 are both divisible by 6. So when I reduce it, it's a 1 out of 6 probability. So let's figure out what this is as a decimal. So again, I'm just going to divide 1 by 6. And when I do that, I end up getting 0.16 repeating. So rounded to the nearest hundredths, I get 0.17, which means that the probability of doubles as a percent is 17%. Okay? So now for example 6, we're going to complete the table below showing all possible outcomes for the sum of two dice. So you're going to want to flip back and forth between pages 7 and 8 to figure out how many, what the sum is going to be. So for example right here, we had a 1 followed by a 1, so the sum of the two dice together is going to be 2. So this right here is going to be a 2. Next one, you got 2 on the first die and 1 on the second die, which means that you had a sum of 3. So right here, we're going to fill in that this should be a 3 right here. Okay. This next one, you got 3 on the first die, 1 on the second die, so 3 plus 1 is 4. Here we're going to do 4 plus 1, so we'll get 5. Here we'll get 5 plus 1, which is 6. And then here, if you get 6 on the first roll and 1 on the second roll, you will have a sum of 7. Okay. For this one right here, if you get 1 on the first roll and 2 on the second roll, then you'll have a sum of 3. And I'm not going to go through the rest of this chart with you guys. I want you to fill in the rest of the chart on your own. So press pause on the video, please. Fill in your chart and then come back to the video and compare your answers with mine. And if you have any questions, let me know and we'll figure out where any mistakes are. Okay? Make sure you give yourselves enough time to check all of these numbers and make sure they're right. When you're ready, press play. And we'll move on to answering these questions here. So question A says, how many possible outcomes are there? Well, it's exactly the same as the last time we did this, but this time we're just calculating the sum as opposed to writing out what both outcomes are going to be. So there are still going to be 36 possible outcomes. And again, we can figure that out by saying that there were 6 outcomes for the first die, 6 outcomes for the second die, multiply those two together, and you end up getting 36. So part B says, in how many ways can the sum of the two dice add to 7? So let's circle all the ones that add up to 7. So we've got 1, 2, 3, 4, 5, 6 different ones that will add up to 7. So we'll say that there are 6 different ways. Okay, so part C says, what's the probability of rolling 7s with a pair of dice? So we'll say the probability of 7, we want the total number of successful outcomes, which is 6, out of the total number of possible outcomes, which is 36. So it's exactly like rolling doubles in the last example that we did here. So when we reduce that, we get 1/6. So the probability of the 7 as a decimal is 0.17, and the probability of getting 7 as a percent is 17%. And if you notice, 7 is the one number that will most likely occur more than any other number possibility that we have here. Okay, so then the last part right here is, what is the probability of rolling odds? So this time I'm going to circle all of my odd numbers and see how many possibilities I get. So we've got 3, 5, 7, another 3, another 5, another 7. We've got this 5, this 7, this 9. We've got this 5, this 7, this 9 right here. We've got a 7, a 9, and an 11. And then in our last row, we have a 7, a 9, and an 11 as well. So if you're to count up how many options we have altogether, we've got 3 in the first row, another 3 in the second row, so that's 6. Now we've got 9. Here we've got 12. Here we've got 15. Here we've got 18. So the probability of rolling odds is going to be 18, because 18 trials are successful out of 36 trials altogether. And since 18 is half of 36, and if you notice every other one is odd right here, the probability is 1 out of 2. Okay, so the probability of odds as a decimal is 0.5, which means that the probability of odds as a percent is 50%. And that's it for the video, so let me know if you have any questions, and we will use this information to apply to some of the things that we'll be doing in class. All right, have a great day.